I/O control. The peripheral device can be controlled by the CPU by using the I/O control unit. However, after the commands have been sent to the peripheral device, the CPU has nothing to do. In addition, the operating speed of a peripheral device is extremely slow compared to the CPU. Because of this, if the CPU must wait until the peripheral device operation is completed, it will be very inefficient. Therefore, for the purpose of increasing CPU utilization, various I/O control methods have been designed and improved. 1. Direct I/O control method. In the direct I/O control method, the CPU controls the peripheral device directly. This is the simplest form of control method. However, the CPU cannot do any other processing while the peripheral device is operating, so it has the disadvantage of having poor processing efficiency. 2. DMA, Direct Memory Access, Control Method. In this method, the main memory and the peripheral device directly input or output data without CPU control. Because the I/O is handled by a dedicated DMA controller, high-speed transfer is possible. It is a method that is widely used for PCs, etc. 3. I/O channel control method. The control of the peripheral device is handled by a dedicated computer called the I/O channel. The I/O channel is also simply called the channel. His method has been adopted by mainframe computers because they have to connect many types of multipurpose peripheral devices. After the channel I/O processing begins, the CPU can handle other processing. When the I/O processing is completed, the channel notifies the CPU of its completion. This notification is called an interrupt and, in particular, the interrupt to notify the completion of I/O processing is called an I/O completion interrupt. An interrupt is a necessary operation to force running programs to be suspended, and to execute other programs, multiprogramming, or other emergency processing measures when trouble occurs. While the CPU repeats basic operations such as fetching and executing, it checks a dedicated circuit to see if an interrupt has been generated. There are several kinds of interrupts. These will be explained in Chapter 5.